So it's been a while since I've last updated the RouterOS version 7 MTCNA guide, and this is actually going to be the next video in that playlist. Hopefully I get to make a lot more videos, but I think this might be one of my favorite topics to cover when it comes to MikroTik and the MTCNA, because this is kind of like one of those core fundamental things, you know, that thing that makes you feel like, okay, I'm actually configuring things on the MikroTik and I'm getting it to do something, even though it's very basic configuration and it's definitely not the most best way to configure things and what I'd say or to be considered best practice, but it's definitely the bare minimum that you can do to get a MikroTik onto a network and to get it to either do its own updates via the package manager, or maybe you can fiddle around with it from your own network just to test some things. But it's really just to get a MikroTik that has no configuration on it, no default configuration. It's blank, it's nothing's on it. You want to configure it yourself. This is what that video will cover, that very bare essence configuration that you require. So let's jump into the video. And again, please like the video if you do enjoy the content, share it if you do feel like more people would benefit from the knowledge, and let me know what you guys think about MikroTik things in general in the comments. So welcome to the lab, and this is where all of the magic happens again. I do use EVE-NG for all of my emulations, and I just have a basic CHR running RouterOS version 7.20 beta 4 inside the lab, and I'll just connect a little virtual PC onto this MikroTik on its Ethernet 2 port, just so that we can maybe emulate a device that was sitting behind the MikroTik. Now, one very important thing that I want to stress with this video specifically, the main topics we will be covering will be how to configure a DHCP LAN client, which will allow the MikroTik to obtain an IP address from a DHCP server, which can be very useful if we would like to get the MikroTik connected to the internet so we can perform some basic stuff like updating the firmware or just doing things, getting the MikroTik onto the network. It's not necessarily that you want to keep the MikroTik in that state, maybe you do. But it's very useful because this means that you could take your MikroTik to your actual network that you currently have. I can plug it into my actual ISP's modem or router. Modem's not really a thing anymore. But then my MikroTik could be set up as a DHCP client. It could get an IP address like any machine on my network, and I'd have internet access. Like, that's the beauty of it. So firstly, we will be looking at how to configure a DHCP client. Next, we will just be looking at how to configure a very basic LAN network where we will assign an IP address to the MikroTik and we'll assign an IP address to a host just to see that the host can actually see the MikroTik. And then lastly, we will be looking at a Masquerade rule on the MikroTik. Now, we will be covering the firewall and DHCP stuff a lot more in detail in upcoming videos, but for the core essence of this section, we will be looking just at a Masquerade rule, which in essence allows our MikroTik a way to provide services to devices behind it to get to the public internet, so to speak. It will make more sense when we do the configuration itself. Now, let's actually look at adding this little device onto the MikroTik. So the first thing I'm going to do is just log onto the MikroTik via Winbox, so I could just find it on my neighbors list, and I can see there's the MAC address, and I can see there's no IP address assigned to the interface that I'm connecting to at the moment, so it's nice and easy. So all that I can do is click on connect, and then once I've connected, now we can start the magic. Now, I want to stress that the first thing we're going to configure is a DHCP client. Now, a DHCP client, if you're not aware what its function is, it's basically just allowing you to specify an interface on the MikroTik that will do the whole DHCP request process, where it will try and find an IP address from a DHCP server. So we'll basically be doing this thing known as the DORA process, and we will talk more of that in detail when we actually go into the DHCP section for the MTCNA guide. But I want you to think of this: every time you connect a machine on the network and it's got DHCP configured, it will basically be shouting, like saying, hey, is there any DHCP servers on the network? And then the DHCP servers, if there are any, they will say, okay, I am a DHCP server. We can see you want an IP address. Here's your IP address. Do you want it? And then the machine will say, yes, I want this IP address, and it will assign it to the interface. And now that device is part of the network. It's part of that subnet. It's able to communicate to anything else inside the subnet. And it might get important details like DNS or it might get a gateway to get to other networks outside of its own network, or it might even get other information like options where you might see things for VoIP phones or cameras where you might want to inject additional information via DHCP configuration. But we will get into that important information in the DHCP section itself. For our purposes, we just need to understand we want to tell an interface it's going to be a DHCP client so it can automatically obtain an IP address. Now to do this, it's very straightforward. We can just go to the IP address settings. We can go into DHCP client. And then from the DHCP client, we can just click on the new button and automatically it will have it enabled. You can set a comment if you want to. And I see when I click on that button, it automatically added it for some reason. I'm not sure if that's normal. Maybe this is something with CHR. But what you can do is just specify which interface this is on. So this is on my Ether1 interface. And then you can see, you can also set it use peer DNS. Now this will basically just let the MikroTik obtain the DNS details from the DHCP server as well, and it will fill that in automatically on its DNS settings. The same for the use peer NTP. If the remote device, the DHCP server, has some time protocol server configured, it can also advertise that to the DHCP client. And then lastly, we can see there's an add default route. Now, very importantly, this is the thing that will tell the device what its default gateway is. If it needs to get to anything that it doesn't know in its routing table, it will use a default route, which you'll normally see as a 0.0.0.0/0 route on the network. Now, we will also touch a lot more on routing in an upcoming video, but for the basics, this is what we do. We just add it to an interface. We can just use these basic settings, just say which interface we want it on, click on apply and OK, and then we'll see it just pops up in here, although mine just automatically did that, so I'm not sure. That's definitely not normal usually, but I do suspect it might be because of the beta I'm using or the Winbox beta even. So what's cool is we can then also just see, it will show us what the interface is, but the nice bit is you can see if it has a status, which might be searching, or if it says bound. Bound just obviously means it's found an IP address. And then we can see how long the DHCP timer is, and that will just basically mean how long it will have this reservation until it needs to say, hey, I'm going to keep this IP. And if it doesn't say it's going to keep this IP, then the IP just becomes available in the pool again. But more on that in the DHCP setting. But here we can see an IP address, namely 192.168.88.229/24, was automatically obtained by my MikroTik. Now the cool thing with this is I actually now have internet access from the MikroTik. Now I didn't show you guys before, but before we added that DHCP client, this MikroTik couldn't get out to Google's DNS. Now if I do a ping, I can get to Google's DNS. Now to do the same setup via PuTTY, it's actually very straightforward. So all that I can do is just log onto the MikroTik quickly. And I'm just going to remove that DHCP client information quickly. So I can just go into the IP DHCP client, and I can just quickly remove the last client we added. And now to add a DHCP client from the command line, it's as easy as just going IP DHCP-client, add the client. And if we tab it, we can obviously see what additional information is required. But we know by default it enables it. It will by default do stuff like use peer DNS, use peer NTP, and it will even add the default route for us. So the main thing that we need to just specify is which interface do we want to run DHCP client on. Now in our instance, again, it was Ether1. So if I hit enter here, it will add the DHCP client to the Ether1 interface. And if I do an IP DHCP client print, we can actually see the same status that we saw earlier on Winbox. I can see in Ether1 interface, it has the peer DNS, it has a default route, it is currently bound, and it has this IP address, which is the same IP address as before. And again, if I do a ping out to Google's DNS, I get a response. So we know this MikroTik has internet access. How cool is that? Now for the next part, let's just add a basic IP address to the MikroTik, so that this machine, this virtual PC at the bottom, can also just kind of get to the MikroTik and potentially also get some internet access out, potentially. So what I'd like to do is just head back onto Winbox, and then from Winbox to add an IP address, again, it's as easy as just going to the IP settings, finding addresses, And now when I click on the new button, I can specify what the IP address is. Again, I can also give it a comment if I want to. So maybe I could add the comment as LAN network. And then with this LAN network or LAN underscore network comment, the address I can specify maybe as 172.16.0.1/24. That will be the MikroTik's IP address. So I'm binding it to a specific interface on this MikroTik. And you don't need to worry too much about this network option. It does automatically fill that in from the prefix that you specify inside the address field. But if you wanted to, you could manually set that to 255.255.255.0. It is that simple. I saw something cool when I hovered over the network, or where was that? That's so cool. I've never seen MikroTik do that before. So if I'm just hovering over that prefix, it's telling me what the range is. How cool is that? I never saw that. That's the first time I've seen that. Anyways, so I know that on my Ether2 interface, I want to be able to add a machine to it, or maybe a switch or the rest of the network or something. But in our case, it's just a single virtual PC. So I'm going to bind this IP address to the MikroTik, and it has been bound. I can see it in my IP address list now. So for my case, I'm just going to log on to this virtual PC quickly. And this is also going to be very straightforward. So I'm just going to add an IP address on it. So the IP will be 172.16.0.100/24. And I'm going to make this device's default gateway the MikroTik, which is 172.16.0.1. So when I hit enter, it will add this IP address to this virtual computer. And if I do a basic ping test from this virtual computer, I should be able to get to the MikroTik's address, since I know it is directly connected. And I do see I am able to get a response. Now the question is, if I do a ping out to Google's DNS server 8.8.8.8, will I get a response from this virtual computer? And at the moment, it seems like no, I'm getting timeouts, even though I know the MikroTik has an IP address. Now this is where masquerading with source-NAT rule comes to save the day. So let's quickly chat about that. So there was just one very important thing that I want to show you before we talk about the masquerade rules, and that is namely adding an IP address from the command line. Now to do this, it's very straightforward. I just want to have a look at my IP addresses. Since I think I did delete it, yes I did, so we don't need to worry about it. So we can just add the IP address, and it's as easy as doing an IP. Let me just maximize that, address, add, and now we can specify what the address is. So I can just type address, and then we'll automatically fill in the equals. Well, I can tab it, it fills in the equals. Now, what was that address? It was 172.16.0.1/24. And if I do a interface, I need to specify what the interface is, which is Ether2, and that is really it. This will bind an IP to an interface. So I can hit enter, and now I can quickly test and see, can I still get to that virtual PC that I added, which was 172.16.0.100, and I can ping it. So I'm very happy with this. This does mean that we have communication on a LAN network scale. So I've got the LAN network working, and I know that the MikroTik's got internet access, but the virtual PC can't have internet access at the moment. And this led us to that point of a masquerade rule, which we'll talk about some more now. Now, firewall rules can be very complex, and there's a lot to cover when it comes to firewall rules. But since we're in this very basic piece of information that I want to just showcase in essence, even though we will cover firewall rules in great details in upcoming videos as well, for our purpose, again, I just want you to think of a masquerade rule as a very clever way of hiding. If you think about it, it's in the word masquerade. You know those masquerade balls where people hide behind masks so you don't really know who they are? It's exactly the same concept in the networking world. So what we could do with a masquerade rule is we could have this virtual PC, when it wants to go out to the internet, where the IP address, so to speak, of the MikroTik. So when the traffic leaves the MikroTik, the rest of the internet will think that traffic is actually originating from the MikroTik, which is reachable for the rest of the network outside of it. Even though the virtual PC doesn't have any type of address to get out to the internet itself, the MikroTik knows how to get out to the internet, and the internet knows how to get up to the MikroTik. So this is kind of where that Masquerade rule comes into play, where we can say, hey, if you see any traffic coming from the virtual PC or the LAN network or subnet or the interface where it's coming in from, you can just hide it when it's leaving my interface behind whatever IP address is bound on that interface. That is a Masquerade rule. Now you can also get stuff like source NAT rules where you can specify exactly what the IP address should be NATed as. But masquerading, it's a very quick and easy one and done type of thing that you can quickly add. And it's really straightforward when you add this configuration. So I'm going to do this from Winbox quickly. So to add the Masquerade rule, it's as easy as going to IP, firewall. Then we can go into our NAT tab. Since this is technically a NAT rule we're adding, if I click on the new button, it is going to be a source NAT chain. And now we can specify a few interesting details. Now, again, we will cover the firewall rules and filters and everything in great detail in upcoming videos. But for our purpose, what I want to do is say any traffic that's leaving, anything that's going out, the out interface is going to be set as my Ether1 interface, my WAN interface, the thing that's actually got access out to the rest of the world, the internet, so to speak. Maybe I want to specify an in interface as well, or maybe I want to specify a source address. So let's do that. That might actually be the most simple thing to do. So I could specify the source address as 172.16.00/24 because that is my LAN subnet range. So now anything from the LAN subnet can get natted out as or masqueraded out as the Ether1 address. If there was some malicious person using some IP address, different IP address, it wouldn't work for them. So that's kind of why it's nice using firewall rules. Now, besides the rule itself, at the moment, we've got the action set as accept. Now, this is where we just need to update the action to be masquerade. And that is so cool. Now we can hide behind the Ether1 IP address. The moment I hit OK, that should actually be it. That should allow the MikroTik to give internet access to the device behind it. So I can see it's currently not seeing any traffic, but that's probably because I haven't tried getting to the internet. So let's go back to that virtual PC quickly. From the VPC terminal, what I can do is if I run another ping to 8.8.8.8, is it going to time out now or not? Let's see. If I do it, ping is working. So I know this device can actually get out to the internet now. And interesting enough, if I go back to my tab on Winbox, I can actually see that 4 packets, and we saw there were 4 pings, passed through this rule and they have been natted out. They've been masqueraded. That is so cool. So now we've actually given basic internet access to a network sitting behind the MikroTik as well. So if my computer was on the MikroTik was now connected via LAN client to my actual ISP network or anything, I have full access like I normally would. I'd be able to do my work even. I'd be able to play games or do anything as per normal. No additional tweaking required up to this. But this is in essence what we want. We want the device to have internet or to have network connectivity, and we've achieved that. So I just want to also show you how to do the chain or the rule from your command line, and it's actually very straightforward. All that we want to do is add a new IP firewall NAT, and I could see it there if I'm tabbing, which is nice to use this command history. It's so quick and easy actually. And then I can just add a new NAT rule. Now there's 3 very important points or things that we need to use inside the rule itself, although there's a 4th thing, which was for me that source address. Now let's just fill in the 3 very important bits. Now the first important bit was the chain, which is basically just saying to the MikroTik where it's going to be working in. If I tab this, there's a few different chains that we get, but I know for our instance this is going to be source NAT. Again, I know I sound like I'm beating a dead horse here, but we will be discussing this in great detail in upcoming videos. But for now, you should just know we're using the source NAT chain. Our action will be masquerade, which is us hiding behind something. And then our out interface, out-interface equals, that is going to be Ether1. So those are the 3 vital bits of configuration to get everything to work. Now, there's a 4th thing again that I'm adding, which is the source-address equals. And why do I add this? Again, it's just like a security type of thing that I like to do. So it's just going to specify anything from the LAN subnet 172.16.0.0/24. Again, there's various ways to do it. You could do it with an in interface. You could do it with prefix lists. Even there's so many different ways that you could get it done, but this is just the very basic bare minimums to do it. So once I hit enter, it will add that IP firewall NAT rule. And if I do an IP firewall NAT print, we can see there is the NAT rule. It has been added. So let's just verify again, do I still have internet access from that virtual PC? I can just ping out to Google's DNS again. And there we go. I'm able to get out to Google's DNS. So I'm very happy. This is really it. This is the core setup for a MikroTik device just to get network access flowing. And again, this is like, even though it's very foundational and very basic, it's also so useful because we can build up everything from here. And this is so fun because from here we get to really start adding more and more and more and just working more with the MikroTik. So this has been really fun for me. I'm going to end off the video here. Again, I'd like to thank you guys for watching. I'd like to thank my YouTube and Patreon subscribers. And I really appreciate you guys for sticking around. Thank you so much, and I'll catch you again in the next video. See ya.